I am from the ISR 3 class here to show my presentation on demonstrating the anchoring effect with the population of a small town. So what is the anchoring effect exactly? The anchoring effect is a cognitive bias that states that the first piece of information someone learns is the most important. The first piece of information that is learned is the most heavily relied upon in the decision-making process. That's because there are two thinking systems in the brain, which are intuitive and reflective. The intuitive system is the automatic system. When you hear a piece of information and answer a question based off of that piece of information, you are using your intuitive system. When you sit and reflect or use other resources, you're using your reflective. So what's the difference between high and low anchor? When you hear a high anchor, this means that you're hearing a large value that will affect how you answer. So when someone gives a large number, the answers that will be given in response will be other similar large values. When you hear a low anchor or a low number or value, that means you'll hear lower, smaller values in response. So why did I use Renville, Ohio to test the anchoring effect? Well, Renville, Ohio is the smallest town of the state of Ohio. I wanted to choose a state that I didn't think would be that well known, and I wanted to choose a state that would have a small population. So as of 2010, Renville, Ohio has 36 residents. I also chose this for its interesting history. The first African American man to receive a medical degree became mayor of Renville, and also it is a relatively unknown town, so not many people are likely to know the answer. My hypothesis for this experiment was that the answers that participants give will correspond with the surveys they are given. So I thought that those who received the high anchor would guess in the hundreds to thousands range, and that those who received the low anchor would guess in the tens to hundreds range. The materials I used for this experiment were an internet connection, Microsoft Forms, Microsoft Excel, and then a question to test, which I chose Renville for. To complete this experiment, first you need to formulate a question, preferably number-based, and after that you create two different surveys to test. In one of these surveys you will replace the real number, in this case the population, with a low number, and then in the other you will replace it with a high number. The numbers I choose were plausible, but this can be done with implausible numbers as well. Then you need to create controls for the surveys to ensure the most accurate data possible. So for what I did for this was I put do not Google the question or ask participants not to Google the answer on the survey questions. Then you send out the surveys to family and friends, and then after that you compile the data from both surveys and then you compare the results. My methods were to give the participants the two different surveys for the population of Renville. I asked my high anchor if the population was over 2,143 residents, and I asked the low anchor if it was over 17 residents. And then I asked on both surveys for participants to guess Renville's exact population by entering a number if they use Google, and then to enter their first and last initials. This slide shows the highest and lowest from both the anchors on the graph. I had 10 total participants for the experiment. The x-axis shows a different number of participants for each survey, and then the y-axis shows the estimated population for that the participant gave. The blue bars represent the low anchor results, and then the orange represent the high anchor results. As you can see, the lowest guess on the low anchor survey was 7, and then the highest guess on the low anchor was 421. And then the lowest guess on the high anchor survey was 1,000, and then the highest of the high was 2,143. I did have to delete some data for this experiment. To make graphing easier on myself, I wanted to have the same number of participants for both surveys. Also, when I initially handed out the low anchor survey, I added the population of Ohio, which is 11.69 million. However, this acted as an anchor of its own and potentially altered some of the earlier results. I removed this anchor from the high anchor survey and deleted 3 of the results shown on the graph in blue. And then I also deleted some of the 11.69 million results, but those wouldn't fit on a graph. I also had to delete the 30,348 because of how big of an outlier it was. but it still shows the anchoring effect. In conclusion, the anchoring effect did have a major effect on how people answer questions. Those who received the high anchor survey never guessed under 1,000 residents, and then people who received the low anchor never guessed over 421. So this showed that my hypothesis was supported and that the first piece of information someone learns is the most important while making decisions. Also, in future experimentation, I would like to make sure there are no confounding variables to mess up the data. So I would do this by only including the high and low anchor instead of including something that might mess up the data like the state population of Ohio, like I did in my low anchor survey. I would also like to test other forms of anchoring, maybe with text-based questions rather than just numbers. This way we could include positive and negative information about a certain subject and have participants tell their opinion of this subject. And then I would also like to track other forms of information, like the time taken to finish the survey, to see if people use their intuitive or reflective systems. And then I would also like to make a survey without controls, without asking people to use Google. This concludes my presentation. Please let me, Coach Lyon, or Dr. Van know if you have any questions while watching this recording. Thank you.